Good morning, students. Chapter 3 Current Electricity continue. Yes, in last lecture we have discussed about Kirchhoff's rule, Kirchhoff's second rule, and yes, it is important. And one question based on that. Now in today's lecture we will see Wheastone Bridge. Yes, Wheastone Bridge is one circuit which obeys Kirchhoff's law. Okay, in which Kirchhoff's law is used. It is application of Kirchhoff's law. Yes, why Wheastone Bridge? This circuit is used. Yes, this Wheastone Bridge is used. Wheastone Bridge is used to find unknown resistance. To find unknown resistance. Okay. Now, what is this Wheastone Bridge? It is one special case. It is one special circuit. See how. This Wheastone Bridge includes total 4 resistors. Total 4 resistors. For example, say it is point A, it is point C. Okay, and another points are point B, and here is point D. Okay, so yes, first resistor is between A and B, between A and B, between A and C, between C and D. Okay, let it is R1, here it is R2, it is R3, and here it is R4. Okay, two diagonals, this point A and B, they are connected with a cell. They are connected with a cell of EMF first. Okay, yes. So yes, there are 1, 2, 3, 4 resistors. These 2 points B and D, they are connected by galvanometer G. They are connected by galvanometer G. Okay. So yes, such circuit is called Wheastone Bridge. Is called Wheastone Bridge. Okay. Having 4 resistors R1, R2, R3, and R4. From these 4 resistors, 3 resistors are known and 1 is unknown. So yes, you have to find which one? Unknown resistance. Clear about this? Okay. This whole circuit is called Wheastone Bridge. Galvanometer. This galvanometer measures current flowing from this branch B. Flowing from this branch B. Okay. So galvanometer. It measures current. It measures current. Okay. Now see, we have 4 resistors R1, R2, R3, and R4. They are connected with a cell of EMF like this. Like this. Okay. It is Wheastone Bridge. Now we will see what is balance condition of Wheastone Bridge. Here, balance condition of Wheastone Bridge. Balance condition of Wheastone Bridge. Okay, yes, it is this such type of circuit is called Wheastone Bridge. What is balance condition of Wheastone Bridge? When we select these 4 resistors R1, R2, R3, and R4 such that, okay, resistances R1, R2, and R4, they are selected such that Ig is equal to 0. Ig is equal to 0 means current flowing from this BD path, means current flowing from this galvanometer is 0. Okay, resistance are selected such that current flowing from this galvanometer is 0, means IBD is equal to 0. And yes, it is possible when potentials of B and D they are same. When potentials of B and D they are same. So yes, when we select resistance such that current flowing from this BD is equal to 0, current flowing from this BD means from this galvanometer, in this case here this current is 0, then such Wheastone Bridge is called in balance condition. Is called in balance condition. Okay, it is in balance condition. It is in balance condition. Now in this balance condition, we will obtain relation between these 4 resistors. How? I am assuming, see here in figure. Let current flowing from this cell is I. Okay, from positive terminal of this cell, I am assuming the current flowing is I. Yes, at point A, this current I is divided into branches. This side, let it is I1. This side, let it is I1. So according to Kirchhoff's first rule, this side it is I minus I1. Yes or no? If at point A, current entering is I. In this branch, current is I1. Then in this branch, current is I minus I1. I1. Now you can say, sir, again there are two branches. So yes, this I1 is again distributed. But no. In balanced condition of Wheastone Bridge, current flowing from this branch is 0. Current flowing from this branch is 0. So yes, this I1 current is from point B. The total I1 current will move towards point C. Current from this branch is 0. Similarly, at this point, I minus I1. Yes, current will not divide. Okay, total I minus I1 current will flow in this direction. Clear? Because current flowing from this is 0. Now, at this point C, I1 and I minus I1 meet. I1 and I minus I1 meet. So, minus I1 and I1, they cancel out. So, what is current? It is I. What is current? It is I. So, yes, see, in negative terminal of cell, current entering is I. Means your current distribution is right. Your current distribution is right. Clear about this? So yes, you have to write one statement. Okay, current distribution is as shown in figure. Current distribution is as shown in figure. Okay. Now to find relation between these four resistors, we will consider some loop. Okay. First, take a closed loop. Which loop we will consider? Yes, starting from A for acceptor A, B, D and A. So take a closed loop A, B, D and A. Okay, so as we are starting from point A, we have to write first of all A. Yes, we are moving A to B. That is resistance R1, current flowing from A, I1. Yes, we are moving in this direction, in direction of current. So it is minus I1 R1. Clear about this? Yes. Then from B, now B2 we have to move towards B. Galvanometer. Yes, students, galvanometer has some resistance, but current flowing from galvanometer is 0. Current flowing from galvanometer is 0. Yes or no? So there is no potential drop or there is no potential rise. Clear about this? So yes, nothing. Then from point D to A, resistance R2, current I minus I1, and see we are moving D to A in opposite direction of current. Then yes, we have to write this plus I minus I1. And what is resistance? Here it is R2 is equal to again at point A, so it is VA cut. So yes, we can write this equation as I minus I1 R2 is equal to, if I take this term on opposite side, then it is I1 R1. Equation number 1. Clear about this? Now take another loop. See, take another loop. Which loop? Obviously from this side, let it is C, B, D, C. Take closed loop. C, B, D, C. Yes, as we are starting from point C, this VC. From point C we are moving towards B. Resistance R3. Current I1. We are moving in this direction, means in opposite direction of current. So I can write it is plus I1 R3. Plus I1 R3. Any doubt? Okay. Then yes, in this branch there is no current flowing, so nothing. Then yes, from D to C, resistance R4, current I minus I1, and we are moving in this direction, so it is obviously minus I1 R4. We reach point C, and yes, here it is. Clear about this? VC cut. Okay. So yes, I can write this equation as I minus I1 R4 is equal to, it is I1 R3. That is equation number. Clear about this? Now take ratio of these two equations. equation 1 divided by equation 2. Equation 1 divided by 2. Now we will take ratio of these two equations. See, equation number 1 divided by equation number 2. See, you are in 12. So we can write this directly. Equation number 1 divided by 2. Equation number 1 divided by equation number 2. See, I minus I1 cancel. R2 upon R2. On left hand side it is R2 upon R2. Clear about this? For right hand side, I1 R1 upon I1 R3. I1 cut, then it is only R1 upon R2. Clear? Yes, you can rearrange this. You can rearrange this as R1 upon R2. R1 upon R2 is equal to R3 upon R4. R3 upon R4. So yes, with the help of this equation, if you are given 4 resistors, 3 known, 1 unknown, you can easily find unknown resistance. You can easily find unknown resistance. Now see here, balance condition means when current flowing from that middle leg is 0, IDD is equal to 0, then Wheastone Bridge is in balance condition. And in balance condition we got this R1 upon R2 is equal to R3 upon R4. We can also say reverse statement. If you are given 4 resistors, means a Wheastone Bridge circuit, and if in that Wheastone Bridge circuit you will get relation R1 upon R2 is equal to R3 upon R4, then yes, current flowing from that middle arm will be 0. Current flowing from that resistance will be 0. Okay, see, R1 upon R2, R3 upon R4. See in figure, R1 upon R2 is equal to R3 upon R4. Here it is R1, R2, R3, R4. Again, R1 upon R2, R1 upon R2 is equal to R3 upon R4. Means ratio of these two resistors and ratio of these two resistors, if they are equal, then Wheastone Bridge is in balance condition. And in this situation, current flowing from this arm is 0. Current flowing from this arm is 0. See, we will take one example. See, we will take one example. Here it is. I will draw another circuit having 5 resistors. What is Wheastone Bridge? See here. If I have one circuit like this, if I have one circuit like this, okay, a cell is like this. Let this resistance is 2 ohm. This resistance is 4 ohm. Okay, it is another resistance. Okay, this resistance is 3 ohm and this resistance is 6 ohm, and it is 5. Clear about this? Then yes, such circuit is called Wheastone Bridge. Such circuit is called Wheastone Bridge. Clear about this? Okay, such circuit is called Wheastone Bridge. Now yes, you can say this R1, R2, R3 and R4. R1, R2, R3 and R4. If you take ratio of resistance this side, it is 2 divided by 4, means it is 1 by 2. Clear? If you take ratio of resistance this side, then it is 3 by 6 is equal to 1 by 2. And yes, here it is R1 upon R2 is equal to R3 upon R4. Yes, 2 by 4 is equal to 3 by 6. Means here this Wheastone Bridge is in balance condition. And yes, in this balance condition, current I flowing from this arm is 0. Current flowing from this arm is 0. Current flowing from this arm is 0. Means you have to eliminate this arm. So how to reconstruct? See, how to draw this figure like this. Like this. It is simple. Cell. Okay. It is 2 ohm. Okay. It is 3 ohm. 4 ohm. And here it is 6 ohm. Clear? When Wheastone Bridge is in balance condition. When Wheastone Bridge is in balance condition. How to identify balance condition? R1 upon R2 is equal to R3 upon R4. R3 upon R4. Clear about this? Okay, so yes, when you are given circuit having total 5 resistances and they are connected like this, it is called Wheastone Bridge. If R1 upon R2 is equal to R3 upon R4, then Wheastone Bridge is in balanced condition. In this situation, current flowing from this arm is 0. So yes, you have to eliminate it. You have to eliminate it. Clear? So now this circuit becomes simple. 2 and 3 in series connection, 4 and 6 in series connection, and then there is parallel connection between them. Clear about this? Okay, yes, you will have numbers of MCQs based on this Wheastone Bridge circuit. Based on this Wheastone Bridge circuit. Clear about this? Okay. Okay, next theory is meter bridge. See, meter bridge is practical application of Wheastone Bridge. In laboratory, you will perform experiments based on Wheastone Bridge and also based on meter bridge. Okay, so yes, we will use principle of Wheastone Bridge. Principle of Wheastone Bridge means when current flowing from that middle arm is equal to 0, Wheastone Bridge is in balanced condition. And in this situation, R1 upon R2 is equal to R3 upon R4. Okay, now what is Wheastone Bridge? Okay, see, we will draw its figure. Here it is. Here it is. Okay, it is circuit of meter bridge. What is meter bridge? See, these are connections, wires we can say, okay, metallic conductors. We have one wire between points A and yes, here is C. Between point A and C. And yes, this battery is connected between points A and C. This battery is connected between point A and C. Clear about this? Remember, Wheastone Bridge cell is connected between points A and C. Yes, between points A and C. Between point A and C, we have one conducting wire. We have one conducting wire. Okay, between A and C, a conducting wire having length 1 meter. Having length 1 meter. That's why it is called meter bridge. That's why it is called meter bridge. So between points A and C, we have one conducting wire of length 1 meter. Of length 1 meter. It is scale. It is scale to measure length of wire. To measure length of wire. It is scale. It is cell. It is key. Okay, switch. Key means it is switch. Okay, now, yes, these are metallic conductors. Here it is one gap, here it is second gap. Okay, between this first gap, one known resistance is connected. One known resistance is connected. For example, it is X. For example, it is X. It is known resistance. It is known resistance. In this gap, another gap, there is another resistance Y, which is unknown. Okay, so yes, in first gap, you have to connect one resistance known. In second gap, you have to connect another resistance which is unknown. And yes, our target is we have to find this unknown resistance. Now from this point is called B. From this point B, from a wire, one conductor is connected, and this conductor, it is like pen. It is like pen. Okay, yes, and that conductor is connected along with one galvanometer. Okay, so yes, from this point we have one galvanometer, and that galvanometer is then connected with a pen, a conducting pen, and it is called jockey. It is called jockey. Okay, yes, this pen is called jockey, a conducting pen, it is called jockey. So yes, it is circuit. It is circuit. Okay, now you may ask me one question. So in Wheastone Bridge we will have 4 resistors, and here there are only 2 resistors. So where are another 2 resistors? Another 2 resistances are resistance of this wire. Resistance of this wire. Remember, Wheastone Bridge, total 4 resistors. In middle, galvanometer. In balance condition, R1 upon R2 is equal to R3 upon R4, and in balance condition, current flowing from this galvanometer is 0. First of all, you have to connect circuit. You have to join this circuit. Once circuit is joined, what is experiment? What is experiment? Take this jockey to this point A. Galvanometer will show some deflection. Galvanometer will show some deflection. Means current is flowing. Means current is flowing. Now you have to move this jockey on this wire AB, on this wire AC. This jockey you have to move on this wire. You have to move on this wire until you reach a point where galvanometer shows 0 reading. Where galvanometer shows 0 reading. Again, what is experiment? If you complete this circuit, you have to move jockey on wire. You have to move jockey on wire, and let at this point, this galvanometer shows 0 current. This galvanometer shows 0 current. Means current flowing from galvanometer is 0. Name this point D. Name this point D. Then now see, if you compare this circuit with Wheastone Bridge circuit, point A, point B, point C, and here it is point D. Clear about this? See, if you know between point A and B we have one resistor, here it is R1. Between point A and D we have another resistance, yes, it is R2. It is R3, and this wire is as resistance R4. Clear? Compare this circuit with Wheastone Bridge. A, B, C, and here it is D. Clear? So what you have to do? You have to move jockey on wire. Okay, what you have to do? Move jockey on wire AC. On wire AC. Find null point. Find null point means what? Where current is 0. Find null point. Find null point. Null point means where current is 0. Where current flowing from galvanometer is 0, or where Ig is equal to 0. So yes, here we have D as null point. Here D as null point. Here we have D as null point. Clear about this? Clear about this? Okay, what we have to do? Move jockey on wire AC. Find the null point, means where current flowing from galvanometer is 0. Here D is as null point. Now as current flowing from galvanometer is 0, Wheastone Bridge is in balance condition. Wheastone Bridge is in balance condition. And in balance condition, what is equation? Yes, we have proved R1 upon R2 is equal to R3 upon R4. R1 upon R2 is equal to R3 upon R4. Now where is R1, R2, R3 and R4? See, here it is. Between A and B, remember, resistance is called R1. So here it is your R1. Yes or no? Between B and C, your resistance, it is called R2. Yes or no? Yes, it is. Yes, it is R3. Okay. Yes, it is R3. Clear about this? Clear about this? Now what about R2? Resistance of wire AD is called resistance R2. Resistance of wire DC is called resistance R4. Now for this, first of all we will assume one data. What data? Let resistance per unit length of wire is, let resistance per unit length of wire is rho. Again, rho is not density, rho is not resistivity, it is again new variable. Resistance per unit length of wire is rho, means if I have unit length, its resistance is rho. Now what is resistance of wire AB? Resistance of wire AD, resistance of wire AD, that is denoted by R2. Yes, it is denoted by R2. Then resistance of wire AD, R2 is equal to what? We have to see. You are given this scale from point A to D. You have to measure this length with the help of this scale. Let this length is L1. This length is L1. Then what is its resistance? What is its resistance? Yes, you know. If resistance per unit length is rho, then resistance for L1 length is, it is L1 rho. It is L1 rho. Clear about this? Yes. So resistance of wire ADR2 is equal to, it is L1 rho. Similarly, resistance of wire DC, this wire DC. Okay, let its length is L2. From with the help of this scale, you can measure its length. So its resistance, I am assuming it is R4. So its resistance R4, it is L2. Clear about this? This L1 and L2 length you have to measure with the help of this scale. With the help of this scale. Okay. So yes, now I have 4 resistors, R1, R2, R3 and R4. So in balanced condition, if I write this equation, R1 upon R2 is equal to R3 upon R4. What is R1? R1 is equal to X, known value. Yes, very good. What is R2? Here it is L1 rho. Here it is L1 rho. Is equal to R3. R3 means unknown resistance, which is Y. Yes, here it is Y. And what is R4? It is L2 rho. Yes, it is L. Again, see, in balanced condition, yes, you know what is relation. R1 upon R2 is equal to R3 upon R4. What is R1? X. R2, here it is L1 rho. What is R3? As shown in figure, it is Y. And what about R4? It is L2 rho. Clear? So yes, this rho cut, and if X upon Y is equal to, it is L1 upon L2. Okay, L1 and L2 you will find with the help of scale. Yes or no? Yes, you can easily find. And if L1 is equal to 60, then what is value of L2? Obviously 40. Why? Because see, meter bridge, we have used one wire of length 1 meter. Okay. Yes, so L1 and L2 you can find with the help of scale. Okay, after you find null point. X is T1, so you can easily find what is value of Y. You can easily find what is value of Y. Y is equal to, make this Y as subject, then Y is equal to X L2 upon L1. So it is how you can find unknown resistance in lab. You have to remember this equation. Clear about this? Yes, you can also write this equation as X upon Y is equal to L1 upon 100 minus L1. But this length in centimeter. Because what is the length of this wire? Again, it is 1 meter, means 100 centimeter. Clear? So yes, Wheastone Bridge in balanced condition, and its application, that is meter bridge. How to find unknown resistance? Remember this circuit, you have to draw this circuit in practical as well. Okay, in practical as well. So yes, if you know what is circuit of Wheastone Bridge, you can easily understand this circuit of meter bridge. Clear? Okay students, now we will see one question based on meter bridge. Yes, you are given this figure only, first figure only. Resistance R, resistance S. In this case, null point from point A, null point from point A is at 33.7 centimeter. Now what is question? If a 12 ohm resistor is connected in parallel with S, a 12 ohm resistor is connected in parallel with S, then find values of R and S. Then find values of R and S. See, yes, it is easy question. Question is long, its solution is very easy. See, here two resistors R and S. 33.7 null point. So yes, it is called L1. Here L1 is 33.7 centimeter. Then what is value of L2? Yes, 100 minus 33.7 means L2 is equal to, it is 66.3 centimeter. Clear about this? Now in theory we have obtained one relation. What is relation? R upon S. R upon S is equal to, it is L1 upon L2. So I can write, therefore R upon S is equal to, L1 means 33.7 divided by, it is 66.3. It is equation number 1. Clear about this? Okay. Now second case, with this resistance S, a 12 ohm resistor is connected in parallel. So see here, what is circuit? R as it is, this as is connected with parallel 12 ohm resistor. So obviously if this resistance changes, overall resistance currents also changes and null point also changes. So in this case, null point is at 51.9 centimeter from point A. Here this is null point. Clear about this? So yes, it is R. We know that this 12 and S, they are in parallel connection. So what is their equivalent resistance? Yes, it is 12S upon 12 plus S. It is 12S upon 12 plus S. Simple. Okay. Yes, here it is L1 is equal to 51.9 centimeter. So what is value of L2? It is 48.1 centimeter. Hello, you have to use formula that you have obtained. R, this resistance upon this resistance. This resistance upon this resistance means R upon 12S divided by 12 plus S is equal to, here it is 51.9 divided by 48.1. Clear? This 12 plus S equal in numerator. So here it is R 12 plus S divided by, it is 12S. It is 12S is equal to 51.9 divided by, it is 48.1. Now how to simplify this? See, you know it is R upon S. What is value of R upon S? Here it is. R upon S is equal to 33.7 upon 66.3. So R upon S I will replace. R upon S I will replace by 33.7 divided by 66.3. R upon S is replaced by this value. So here it is 12 plus S upon S is equal to 51.9 upon 48.1. So yes, now in this equation there is only one variable, that is S. Clear? So yes, if you solve this, you will get value of S. And if you put value of S in this first equation, you will get value of R. So yes, it is one simple question, just you have to understand its language. Okay, which resistors are in parallel connection. Be clear about L1 and L2 and what is equation. Clear? Find answer of R and S and write your answer in comment box.